Welcome to today's webinar on SDS2's intelligent automation of steel detailing. Today I'm going to go ahead and cover how this solution could benefit your company. So a little bit about us. Who is SDS2? We're one of the global leaders in steel detailing software, and we're also the market leader in the Americas. We're founded in 1981 by a steel detailer, and we're also part of the Nemetschek Group. We're expanding internationally, but the quick expansion has been slow due to the code-based design requirements, so like the connections. We do have a presence in 17 countries, and the international growth is set to accelerate with the support of Nemetschek. We do primarily steel detailing, but we also do have a concrete package. We have a structural BIM model. Everyone's needing BIM models these days, but we also provide the steel detailing BIM model, so it has the structural integrity behind it. We not only do that, but we're a constructible model. We make sure that everything is actually constructible and erectable out in the field, and I'm going to cover that later on. And then we have drawing production, so there's not as much cleanup in our drawing production, but also we have an intelligent automation of steel connection design. So every time that you make a connection for, let's say, a beam to a column, it always will provide the design calculations and quickly fire those off. So why use SDS2? It's fundamentally different than any other steel solution. It's built around the intelligent automation of steel connections, which I'm going to dive into this quite a bit deeper later on. The SDS2 connection design is the most automated solution in the world, so we haven't found any other solution that is able to automatically look at your code base that you're using and go off of all of your setup options, put in your loads, and then it's going to automatically figure out how many rows of bolts, what connection to use, and then back it up with the design calculations. The drawing requirements are very minimal for the cleanup, and we offer additional services too. You may not be offering connection design services at this moment, but SDS2 does make that possible if you're looking to expand in the future. So why should I care about connection design? What if I don't want to do connection design? What's in it for me? Here's the typical detailer workflow. So you have a frame design that comes from the engineer. They say what type of connections they want, and then they send it off to the detailer. The detailer then creates his shop drawings, and maybe then they have some questions about the connection design. They send an RFI back to the engineer. The engineer then looks at the RFI, makes the changes in the connection design, sends it back for the shop drawings, and then once that's done, it can go off to the fabricator. Now, the fabricator might then see that there's some issues, then they send it back to the shop drawing or the detailer, then they send it back up to the engineer. So it's a whole bunch of RFIs, then it goes back through the detailer, back to the fabricator, and then off to the erector. Now, the erector starts trying to put this up in the field and realizes that it can't actually put that beam between the flanges of the column. So then it has to go all the way back up to the detailer, go up to the engineer. So then they need to make the changes and then they send it back to the erector. The erection's delayed waiting for the engineer, the detailer's involvement is prolonged, and the additional work is often not billable. The project can be delayed, causing the overall construction delays and additional costs. So what's so special about the SDS2 connection design? So the first one is the steel connection design. Okay. So then we also have the structural integrity. The structural integrity will look at that and back it up with design calculations. Okay, so RISA, RAM, they might be able to do that too. Then we take that to constructability. You want to check for constructability, which most software solutions will already do this too. And then we take it to one step further for erectability. So like I stated, can that beam actually fit down in between the flanges of the column? Can it actually fit down there? So nothing else does all three. In fact, nothing else does more than one, and we do all three of them. Now let's just take it one step further. We can look at the complete node. So all of those members framing into that, let's say a column. You have some framing into the flange, you have some framing into the web, you have some maybe braces framing up to that node as well. It looks at everything framing into that situation when we design the calculations, and the connection. I could also do the complete structure. So I could do all of the, maybe I want an end plate for all of my wide flange beams framing into the flange of the wide flange columns. I can do that in my setup, and I can do this for my complete structure all at once. And complete control. So I could take that one step further and say maybe how thick I want the plates to be, or what spacing I want those bolts to be. So I have the complete control of that, and I'll kind of get into these further on. And we have complete optimization. So the optimization, maybe you care about bolts. We can minimize the number of rows of bolts so it can save you on a connection, which I'm going to go into a little bit later on. And that saves you a little bit on one connection, but if you have 1,000 connections, it could save you a lot of time and money out in the field. This has the complete, intelligent, automated steel connection design within your steel detailing solution. Now let's just go ahead and dive into these individually. The structural integrity. So what we do, like RISA, RAM, LimCon, DESCON, most of these do the design check, but they don't do an auto design. They're just a single direction. We look at all the directions framing in to that connection right there. We also check for 28 limit states, and it could be up to 25 pages of connection or calculations if you want, but clearly we don't want that many. Also constructible. So all detailing software should be able to do this. It's a high level of detail. The beams are cut back. It shows for bolt clashes and make sure that you have accurate gusset plates. But let's take that for erectability. So this is completely unique for SDS2. It reduces your field issues. So as you can see down here, my bottom flange is thinned out. So not only is it so that it can fit down in between the flanges of that column, but also maybe that beam that's framing into the flange, it was erected first, so I don't want it, you can see over in the right picture, I don't want it to interfere with those bolts. I don't want that beam to interfere with the bolts framing into the flange. So it kind of copes it out or thins it out to make sure that it can slide down there with no erectability issues. Another one is the shear plate. So let's say the shear plate was already onto the column. I want to be able to cope that out so it can slide down in between the flanges so that it's erectable out in the field as well. Then at the bottom flange here, since it's coped out, it's not going to interfere with that shear plate that's already on my column. Another thing is maybe I have slip critical bolts on this. So if I have slip critical bolts in, instead of having to use a wrench there, then I can actually extend that shear plate out so I can use a TC gun instead for the bolt pass. It looks at the complete node. We've already kind of talked about this, but it looks at every single member framing into that node. And then it makes sure that it's all going to be erectable, and it checks for the clash detection. The complete structure, like I talked about, it can auto-design all of those members at once, and that will cut back on a lot of time saving. And then this is all of our setup. So there's many design and manufacturing settings that you can take control of, and then you can work with the fabricator on how they want these to get output. When it comes to optimization, so this would be for somebody that actually cares about how many bolts are or how much money that they're spending on the bolts. So usually, yes, you just maybe, or I guess what the practice used to be is just fill that beam up with bolts. Instead, there's a couple settings that you can tweak on here. And instead of using 7 rows of bolts, it went to 5 rows of bolts, but it still passed that connection. So that's just another automatic optimization that you can do. And then maybe more of a manual one would be, so I have this moment connection here, and it's calling for web doublers and web stiffeners. Now that's going to cost me about $700, including the material, the bolts, the holes, the preps, and everything. That's not including my wide flange actual material. So that's going to be about $700 for a W14 by 43. Now, if I were to manually change that and up that to a 14 by 68, that might be a little bit more cost inside of how much it's going to be for the actual column, but it cut it down for by almost $500 for just my connection. So it saved me on my material, it saved me on my welds, and all of that information as well. So that's just another way that you can do that. While the detailer may not want to take on the liability for connection design, having a connection design capability can result in significant time savings. So let's say the engineer is going to send me that frame design. It's going to go through, I'm going to do my shop drawings. I might have a couple RFIs sending to the engineer about my connection design. Well, then that can go to my fabricator, and then the fabricator can go to the erector. The detailing process is going to be a lot shorter due to the streamlined connection design, and then we already do the constructability and erectability checks. All right, so now I'm going to go ahead and pop out and go into the actual demo. Now that we've gone over what's unique about SDS2 in the slides, I'm going to go ahead and apply this while building my model. Working in the split windows is going to allow me to have multiple views of my model at the same time. I can set a tile active so that I can only make modifications to that window, or if I have all the tiles active, then I can add my members across the different tiles, which you're going to see a little bit later on. You can import a 3D model from a different software such as Revit or S3D and build off of it to estimate from. If you're building the model from the ground up, then you can overlay 2D design drawings in the 3D model, which will allow for a quick member layout. So reading the section sizes from my design drawings, then I can use that quick add tool that allows for very fast modeling. As you can see, adding the columns in on the right hand side in the plan view, they're also populating over on my left side in the ISO view. When members are added in SDS2, they read from the setup options on how the piece marking is going to be created. In this example, you can see the system is batching all the like piece marks together. If I wanted to, I could have my piece marks broken down into sequence. Even if my beams were identical, then they would have different piece marks because they're in different sequences. So therefore, we wouldn't want to fabricate all of the items at the same time. So now I've moved on to my second floor. I'm going to turn on my 2D drawings for my beams, and then reading from my section sizes, I can use that quick add tool again. I've now moved on to the second floor, and I turned on my 2D drawing for my beams. I can then read my section sizes from my drawings and use that quick add tool again. I could even come in here and set up my connections, what type I want, instead of going into each member edit screen. I'm also going to turn on continuous so I can go around the perimeter of the building without having to stop. As soon as my beams are getting placed, they're going through piece marking and connection design. So let's say that I want a wide flange beam to the flange of a wide flange column, and let's say I want a clip angle connection for the majority of my job. Not only is it going to go through the connection design, but it's going to also make sure it's constructible and erectable like we talked about in the beginning. There's no guessing with our software, and so what you get in the model is going to be what you get in the field. As I'm adding in the members, I've been using our toolbars, so you can see around the perimeter of my model there's a whole bunch of different icons. So these can be customized per user. I use some tools often, so I've just placed them on my toolbar. Our customers have requested to do this rather than ribbon just because it would slow down their productivity. As stated previously, when members are added in, they undergo the piece marking. The horizontal beams in the center and the top are identical, so they're going to get the same piece mark. Since these floors are going to be identical minus the horizontal brace, I can just copy them up to the intended floor elevations. Using my UCS and ortho commands, I'm able to quickly copy these members in my isometric view. In this example, I want to pick my points for copying. If all my floors were at 15 feet, let's say, then I could use that linear copy mode. Being able to copy the floors with their intelligence will save quite a bit of time for this large structure versus having to model in each floor by hand. As soon as these floors are copied, then they undergo the intelligent connection design, do the erectability checks, and then make sure the joint's actually constructible as well. So I got the set of drawings for the bid, and then I quickly put in this small structure. Now that I have the primary members in, I then can have a baseline estimate for my bid. A number of our customers are already estimating from the model, so this isn't anything new. The next logical place to look to gain efficiency would be in the estimating part. The more bids you get out, then the more opportunities you have to win the work. You want the turnaround to be quick but accurate, and with the cost estimating tool, it'll calculate my material costs, my hole costs, my weld costs, and etc. Then I can look at this in Excel. In the Excel file, it's kind of broken down into materials, bolts, holes, welds, members, etc. This isn't to replace your MIS software, but it's just to give you a baseline. In my model, I already have everything set to clip angles, but I want to change all of my wide flange beams to the wide flange columns framing into the web and the flange to shear tabs, so I can compare the pricing between the two. Auto standard connections are going to be for the majority of my job, so every time that I have the wide flange beam framing into the flange of a wide flange column, I want it to be a clip angle, shear tab, or maybe an end plate. I can always override these. Since I changed something in my setup after the members were already in, I just mark it for processing to undergo the new changes. Submitting your model during the bid process may help as well if design changes come back and then they weren't in the bid. You can then use the submitted model as proof of what you based your estimate off of. After changing my connections to shear tabs, then I can rerun my costing tool. This will then be able to do a comparison between my clip angles and my shear tabs. As you can see that it's gone down to actually $36,000 for my material costs, but my weld cost has increased to around $3,000. If I open this up in Excel, you'll remember that it was $1,500 for my welds and it was about $37,000 for my material when it was clip angles. So this looks like it pretty much balances out. I can also run an advanced bill of material after this. I'm going to go ahead and create a new one really quick. You can then modify the setup in the general settings, some length rounding options, and more operation additions. Then once it's created, I can review it and send it off to my MIS software. So this is just another way that I can do a material takeoff, and then I can even review it in Excel. So since I'm going to do shear tabs on this job, I now want to see what connections are going to be failing. Running predefined statuses for my job can help me determine which members are failing or any high cost items. Up here I have my truss. It was passing with my clip angle connection, but since I changed it to shear tabs, it's saying that there's going to be SC bolts required. I'm just going to change this back to clip angle because I knew that it passed. Once I update something in my model, the status is automatically going to update as well. And so as you can see, the color has gone away from that truss now. I'm now going to move over to my shear tab connection and actually change this to a bolted moment connection. As you can see in my member edit screen, it allows for a lot of control of each member. It's easy to hide what you don't want to see by clicking on the blue items on the left side. I'm just going to leave all my loads at default and see what it gives me. Maybe here the loads are a little bit conservative for this connection, and I'm going to write a model note for the engineer to check the loads. By default, we design at 50% of uniform allowable load and 85% of maximum allowable moment. When designing connections, it's going to go off of your design code provided. So currently we can do ASD, CSA, LRFD, Eurocode, and others. If the engineer does not have SDS2, you can either send out an RFI that they can view in a PDF viewer, or they can also open up the free SDS2 viewer. I'm going to open this up, this RFI, in my PDF viewer, which is going to be Bluebeam. The engineer then can look at the properties and determine if the load can be lowered. Then they can send that information that they find back to the detailer or whoever oversees the updating of the model. That person then can create another model note to lower the load and change the color so that the detailer can see this change. Any joint can individually be changed from what the default was set to. Every time that it changes, it's going to go through the intelligent design checks and then make sure that the flanges don't interfere with each other and that the beams can fit down the column web. Those are just a few examples that it checks for. Now that the loads have been lowered, you can see the connection is a lot more reasonable. There's two different types of calculations that the connection designs every time something is modified on that joint: the design calculations and the expanded calculations. The expanded calculations are going to show all of the longhand formulas, like you can see, that our engineers went through to get the calculation based off of the setup, the loads, and the design method. The design calculations have the same information, it just does not have the longhand formulas. After rotating that column 90 degrees, you'll see that the connections update. Like I mentioned in the slides, a unique thing about SDS2 is that it doesn't just look at one connection framing into the joint, but all the members framing into the joint. So it also makes sure that these connections are going to be still erectable after that change. Anytime a modification is done to a connection, the expanded calculations and the design calculations are going to be regenerated every time. Making a change to a single connection is as simple as just editing that end and locking the variable. On the left side of the window, you're going to see the end's limit states and if that connection passed or not after my change. A system design connection will design around that locked field, so the 4 rows of bolts. Now I'm going to save that as a user-defined connection and I want to apply that to all of my W18 beams. I can select all my W18 beams in a few different ways in the model, but one of them is going to be advanced selection. This tool can be very powerful if I want to highlight on a specific property on my member or the material. We have predefined advanced selections created, or the user can write their own to make it more customized for their company. When I have them selected in my model, then I can multi-edit them and just apply my user-defined connection. Calculations are still going to be created for the user-defined connection along with making sure it's going to fit in the field. I can then copy my user-defined connections from job to job. Now, applying components to members is going to save a significant amount of time when modeling the odds and ends of a project. The components, such as this outrigger, will have parameters to fill out instead of modeling the plates one at a time. The components then will be attached to a member and have the intelligence to adjust if a change order is made to that beam. I can either make the modification on the component through the member edit screen, or I can double click on the component itself. Components can be copied between different beam section sizes, but they're going to still have the intelligence to adjust to the correct plate sizes. So I'm going to go ahead and add a hole to this plate. SDS2 is going to see that there's identical materials actually attached to this beam that I'm adding the hole to. Instead of having to add a hole to every single plate, I just need to check on to add all like material on this member, and then you'll see that the hole is added all at once. Now components are attached to our members, but when I add one to my roof, it's going to be actually its own member and a detail. So we have custom members inside of SDS2. That's going to make modeling and secondary steel easier. I have a roof frame that I need to put in, and the list are all the different member types that you can add inside of our software. The status bar in the upper left corner will tell the users what action is needed for the command they're in. Once in the roof frame boundaries are placed, then I can fill out each field or load my company standards form. The custom members or secondary steel does not go through the connection design, so the connections can be designed however you wish for the shop. So keeping along the lines of secondary steel, I'm going to move on to the stairs and handrail. I'm just going to hide these members for now and then I can bring them back later on. Turning on the 2D drawings like I did in the beginning for the beams and columns for my stairs is going to be a quick way to lay out what my stair stringers need to be instead of measuring for each elevation landing. I can add a single stair or a tower stair in the same view. Using the Stair Quick Add tool, then I can add all 4 of my stairs in a single command. As the points are being picked, then I can define the top and the bottom of my stairs and then the horizontal nosing to nosing dimension, and all of that information is actually calculated as I move up the drawing. When I'm completed with the Stair Quick Add tool, each stair is going to be broken out into its own member and piece mark. These can be then edited if needed, and then once I'm finished out with my layout, I can just turn off my 2D drawing overlay and add in my handrail. Adding the handrail by simply selecting the stair stringer has saved our customers a lot of time for not having to lay out the points to pick. I'm going to load another company standard form because I know that I want my handrail welded to the stringer, and I also want the connection type to be welded. Below are all the connection types that we offer for the handrail. Since we're still in the command, then I can continue and go up the stair tower and apply all my other handrails. I could fill out the same variables each time, but since I've already created these forms, it's going to cut down on a lot of my rework. So when adding in the handrail, it's now going to be associated with the stair stringer. If I were to make a modification to the height of the stair stringer, the handrail is going to adjust with it if my pens are activated. Once finished with adding in the handrail and the stringers, then we're ready to combine the handrails at the landing. I can connect the handrails from the stringers and go around a parameter, but in this example, I'm just going to close it off by simply selecting the member ends of the handrail that are both on the stair stringer. A form could be loaded, but for now I'm just going to add a grab bar so it continues all the way around the landing and connects into the handrails on the stringers. I'm going to go ahead and continue to connect these at the landing going up the tower stairs. The handrail window has a lot of options for the user from material type to splice distances to just adding a wall rail. Now, once these are all finished, let's say I have a change order that came back, and I need to change my rail spacing from maybe 4'2" to 3'8". Instead of having to delete all my handrail out and moving each post, I can select all of my handrail on my stair stringers and my landing at once. Another change order that came back that wasn't caught in the beginning was maybe that these handrails needed to be galvanized. I could have had these checked on in my quick add tool for my handrail, but you can also edit these after the initial input. I have the different plug types such as zinc plug, plug weld, aluminum, epoxy, or no plugs, and that I can add to my posts and my mid rails. I also left it at internal and external for my post, so as I zoom in here, you can see that everything has been created now as galvanized enabled. We've been working with the AGA, or American Galvanizers Association, to come up with different checks for our members. I'm going to check on for kettle tank fits, maybe conflicting material thicknesses, proper vents and drains. Maybe I also want to check against the crane capacity. I just need to select the members that I want to include in the check, and then it will give an output on what passes for my checks. There are also setup options for how big I want the kettle defaults are, my default vent drain hole diameters, and then what type of plug type I want. Now here's the output that it's showing me everything that's passed for maybe my crane capacity checks and my material thickness checks. I now want to add the handrail around my balcony up on the roof. There are always multiple ways to achieve something in SDS2. I'm going to take advantage of the tiles that I used in the very beginning and add my handrail in an isometric view and in my roof plan. I previously continued the flat rail which connected existing handrails. Now I want to add in handrail from scratch. I'm going to go ahead and set up my views here so I can pick my correct points. With the handrail quick add, I start establishing the parameter. Utilizing the tiles, I can start off in my roof plan, then continue around in my isometric view, and then end up back in my roof plan view so I can end my splice right at the concrete wall. I have an offset out from the center of the beam because I want this connection to actually be a shear tab going around the balcony. When I'm finished with the handrail quick add, then I just want to load my form for the balcony that I set for my shear tabs. I can change this back to one tile since I've finished adding in the handrail. Zooming in on the handrail, it automatically detects my near side and far side for the toe plate, and I have my shear tabs offset by 5.5 inches. Now I'm ready to add in my Embed Angle layout tool. This can be used for decking on top of my concrete wall for this example. You may be used to building a boneyard for your secondary steel. So with the tools in SDS2, your BIM model is going to be accurate and represent all of the material on the site. I want to put in my embed angles to support my decking that's going to be sitting on top. By adding these in, it's going to check for the interferences with the joists and the concrete wall. This way, it will check for this before they get fabricated and shipped to the field. This is also going to cut down on my construction time since we'll have an accurate quantities and everything's going to fit properly. Then I could send out this LOD 400 model with all of the material and my secondary steel included. Then the other trades involved on the project, they can plan their work packages based off the model that I've provided. So therefore everything's going to be accurate. So showing off everything in the model is great and all, but what do the drawings look like? I'm going to detail my members, the submaterial that's attached to those members, and a couple of erection views. In this erection view, I'm going to turn on my member style to wire, and then dimension my anchor bolt layout. I'm also going to scale up my anchor bolts to maybe 1.25. For the majority of my erection views, I already have my default set up how I want them, but for my anchor bolt layout, I want to make sure that my base plates are showing and all of my base plates are detailed. SDS2's automatic detailing routines create a set of drawings that take less time modifying than any other system. Now entering into Drawing Editor, I'm going to quickly show what some of the drawings look like out of the box with no cleanup done at all. We do offer a template service that's going to customize the drawings to your shop's needs. Just for this example, I have detailed a drawing without templates, and now I'm going to detail with templates. If your company needs to remove a specific dimension or add one, that might not be much work on one drawing, but it can start to add up if you have over 100 drawings. A complete bill of materials is also going to be provided for every member type every time it's detailed. Moving on to my erection views and looking at my anchor bolt layout first. I changed my member style to wire, and my base plates are called out, and everything looks dimensioned. My grid line 5 is where my bolted moment connection was framed to the web of the column. I actually want to have a magnified view, and I want it to be wired here. First, I'm going to get rid of some of the callouts. We provide easy cleanup tools for the Erection Views. I can edit what I want to show fast in the Erection View cleanup by just selecting the members that I want to include and then having all of my callouts disappear. Then I can zoom in and this little triangle is my moment connection. So I want to create a magnified view of the moment connection for my engineer to see on the Erection View. The drawings are going to be where I make any of my modifications. I'll put them on sheets and send them off to the checker for approval. Even if the drawings are on the sheets, they can still be modified and any of the changes done on that drawing are going to be reflected onto the sheet. When editing the magnified drawing, this will only reflect changes in the box of the Erection View. Changing the member style can be done on the Erection Views or in magnified drawings on the fly, and you don't have to redetail the entire Erection View if you're wanting to update them. While I'm here, I'm actually going to change the column and the beam framing into the flange as wire as well. When I'm finished, I want to hit save for all my changes are reflected inside that magnified box. There are no changes that happen inside of the actual Erection View. I'm now ready to place the Erection Views on their corresponding erection sheets. When placing the drawings onto sheets, you'll select the sheet outline first. This would be like your company's title block that could be imported in as a 2D DXF, DWG, or DGN file. You will want to make sure that you have the updated bill of material with ours to make sure it's intelligent. So I've placed one Erection View on there, and now I want to place my anchor bolt layout. By default, we have a few different sheet sizes. For my anchor bolt layout, I'm going to pick a D size. I know that this is a little bit smaller, but I can always scale it up. This will also scale my labels up. This is not going to affect the view itself, but just how it appears on the sheet. Now moving on to the detail sheet autoloading. This is a way to load multiple details onto a sheet at once. Over to the right-hand side are my Piecemarking renaming options. This would be if I want to create a shipping mark for my company. So my default, the sheet name is going to be first, my member type second, and my placement's going to be third. Since I'm going to load my beams, it's going to be 1B1 for example. Once I've renamed the beams and renamed them onto my sheets, they would automatically be updated in my model, on any drawings, and on my Erection Views. So since I'm just doing this order, you can also do them onto sheets first and then come back and make modifications onto the drawings. Everything's going to be reflected back on the sheets. So my fabricator just called and he actually wants a list of all my piece marks for my submaterial. Reports can be a pretty easy way to extract data from the model or your bill of material. We have a lot already created, but a user can also create their own for their company's needs. So here's an output for my submaterial piece mark list. The next report I want is actually going to be for my field bolt summary of the entire model. The report's going to be broken down into my bolt finishes. So I have black, and then I also have those hot dip galvanized for my handrails. Since I now have my model finish, I want to create a transmittal to batch all of my information and send it out. I've already created a configuration that I want to use. It's going to create my PDFs of my erection sheets, detail sheets, my CNC files. I want an IFC of the entire model. So once that's done, it's going to create a folder. Inside of that, I have everything that was created from the transmittal. Here are my CNC files that actually pull from my model. And in my configuration, I've extracted my DSTV and my DXF plates. So another thing that I want to see are my detail sheets. I created PDF files of these detail sheets, and I'm going to open them up inside of Bluebeam again. You can see that everything that I saw inside of Drawing Editor is now in the PDF format, and I can send it out to my checker. Thank you for joining me in today's webinar on SDS2's intelligent automation of steel detailing. We've covered both the 2D and 3D, designing connections that are intelligent, constructible, and erectable models.